Hello everyone! Today I would like to do MP-BGP or Multiprotocol BGP configuration and verification. And before we continue, I would like to ask you to subscribe to my channel with notification bell on, and please show your support by hitting like button. So let's do it. So this is the network which I'm planning to configure today. We have three routers, R1, R2, R3. Each router has two loopback interfaces, and each interface has two IP addresses configured for IPv6 protocol and IPv4 protocol, and I'm planning to configure MP or multi-protocol BGP, and then I'm planning to do route summarization or address aggregation for IPv6 in BGP for loopback interfaces, for subnets on loopback interfaces. And I'm going to focus only on IPv6 because IPv4 I did in the previous video. If you want, you can go and watch it. So let's do it. So this is network for today's example. I already configured IPv4 and IPv6 addresses on all devices, and I can start MP-BGP configuration, but first let's verify. So IP interface brief. IPv4 configured, IPv6 interface brief, all IPs are there. Let's go to router R2. IPv4 addresses, IPv6, and let's go to router R3. IPv4, show IPv6 interface brief, and IPv6. Let's go then to R1 and start BGP configuration. Conf T. Now I need to enable the unicast routing for IPv6, IPv6 unicast routing, and router BGP 100, BGP router ID 111. Let's do neighbors. 10.12.02 remote IS200. This is our router R2, one link, and second link, and then neighbor 10.13.03 remote IS300. This is router R3, one link, and second link. And now let's do neighbors for IPv6. Neighbor 2001 DB8 0 12 00 2 remote IS 200 second link, and for router R3 DB8 0 13 3 remote IS 300, and second link like this. Now we need to go into each address family and activate our neighbors and advertised networks. Let's start from address family IPv4 unicast, and then we do neighbor 10.12.02 activate, 10.12.066 activate, neighbor 10.13.03 activate, and 66 activate. And then let's advertise networks. Network 192.168.1.0 mask 255.255.255.224 to show run interface loopback 0 mask 224, and second one 32. And now we need to go to address family for IPv6 unicast and do the same. Neighbor 2001 db8 0 12.0.0.2 activate, second link activate, and then 2001 db8 for router R3 0 13.0.0.3 activate, and second link. And now let's advertise our networks. 2001 db1 is 1001 and second 1001, db8 0 1064 and second one 1001. So we are done with router R1, and let's go to router R3. Oh, sorry, R2. Conf T. Same IPv6 unicast routing, router BGP 200, BGP router ID 222, and then let's do our neighbors. Neighbor 10.12.0.1 remote IS 100, second 165, and for router R3 neighbor 10.23.0.3 remote IS 300. And now let's do for IPv6 neighbor 221 db8 0 12.0.0.1 remote IS 100 and second link 1. And for router R3 neighbor 2001 db8 0 23.0.0.3 remote IS 300. Now let's do address family IPv4 unicast neighbor 10.12.0.1 activate, 65 activate, neighbor 10.23.0.3 activate, and network 192.168.20 mask 255.255.255.224. These networks are our loopback interfaces. To show IP loopback 0, to show IP interface loopback 0. Let's do like this, to show run interface loopback 0. So this one, and second one for this one. So I activated, I advertised this network, I need to do second one. 32. Okay, and let's go to address family IPv6, address family IPv6 unicast, and do our neighbors. Neighbor 2001 db8 0 12.0.0.1 activate, 1 activate, and for router R3 db8 0 23.0.0.3 activate. And let's advertise networks. Network, so we have these two networks, 2001 db8 0 200 64 and second one 1. And that's it for router R2, and we can go to router R3 and let's verify. Show BGP, show IP route BGP. If we have already, yes, we already got routes to loopbacks on router R1. Show IPv6 route, show IP. So yes, so IPv6 route BGP and the same for IPv6. Let's go to router R3, conf-t, IPv6 unicast routing, and then we do router BGP 300, BGP router ID 333, neighbor 10.13.01, remote AS 100, and second one 65. And for router R2, neighbor 10.23.02, remote AS. And let's do for IPv6 0 1300 1 remote IS 100, second one, and for router R2 neighbor to 1 db 80 2300 to remote IS 200. Okay, this is done, and now we need to go into address family, IPv4 unicast, and activate our neighbors and advertise networks. Neighbor 10.13.01 activate, 13.065 activate, and neighbor 10.23.02 activate. And then we need to advertise our network from loopback interfaces to show run interface loopback 0, this network, and this one for IPv4, and this network, and this for IPv6. But for this, for address family IPv4, we need to do IPv4 network 192.168.3.0 mask 255.255.255.224 and network 32. Okay, now let's go to address family IPv6. Address family IPv6 unicast neighbor 2001 db8 0 1300 activate, and second one this one, and for router R2 2001 db8 0 2300 to activate. And let's advertise our networks. Network 2001 db8 0 300 64, and second one this one. So we configured MP-BGP, and now let's verify. Let's go to router R1. Let's run some verification commands to see if everything is fine. First command is show BGP, and then we have all for all address families, neighbors. So we have our router 222, one neighbor, this is second link for this neighbor, then we have router R3, first link, autonomous system 300, BGP state established, version 4. Then we have hold timer, keep alive. And second link for this, the same router R3. So this is, so we have connectivity, we have relation adjacency formed with router R2 and R3, and that we can see in this command. And then let's do separate, show BGP IPv4 unicast and summary. So this is sessions, and we can see here our router identifier, autonomous system, memory used, and our neighbors, version, autonomous system, received, sent messages, BGP table version, up down time, and received number of received prefixes. And the same for IPv6, we can do the same, and we see the same router identifier, local autonomous system, BGP table version, and also memory used, and we have our neighbors, router R2 and router R3 with 2 links, autonomous system. Let's try again. Autonomous system, received messages, sent messages, top down, and prefixes received from neighbors. And let's do this command. One 192.168.2.0.255.255.255.224. We can see routes, and this one is the best for this subnet. So we have 2 from one link, through one link and through second link between R1 and R2, and this one is considered the best. It is the same, like if you can see here, but more detailed. And the same command we can do for IPv6, 6 unicast, and let's do 2001 db8 0 2064. And you can see we have this is our loopback on router R2, so we can go, and this one is the best, which goes through router directly to router R2. And let's see. If we do loopback from router R3. Okay. Next command is show BGP IPv4 unicast neighbors, and then one 10.12.0.2, and then we can check, for example, advertised, display the router advertised to this BGP neighbor. So advertised routes, and we can see which routes we advertising to this router. Let's do the same for IPv6. (2001) DB8 0.12.0.2, and here we are advertising these routes. Loopbacks, advertising back this loopbacks from router R2 and from router R3. And last command which I wanted to show, actually this is obvious command, show IP route BGP to check routes in routing table for BGP. We can see these routes, and let's do for IPv6, and we have routes for IPv6. So that was everything, all commands that I wanted to show for verification. And the last thing I wanted to show today, let's do aggregation of IPv6 addresses on loopback interfaces on each router, because we have, as you can see, we have two, so we can aggregate them into one route, and we're gonna have only one route instead of these two, and one route instead of these two. So let's do first conf t router for, if you want to see the same aggregation for IPv4, you can watch previous video. There I did aggregation or summarization for IPv4. Routing or router BGP 100, address family IPv6. It needs to be done under IPv6 address family, unicast, and then we have aggregate address to do 1 DB8 0, and let's first see what we have. To show run interface loopback 0 and loopback 1. So aggregate address to the 01 DB8 0. I will aggregate up to this part, so it's gonna be subnet 60, mask 60. It's gonna be 000 and then 60. So this one is 4-bit and this one is 4-bit. We have 64. We aggregate up to this part, so it's gonna be 60. Let's go to router R2 and let's verify. It should be already there. As you can see, we have already our aggregated route, but we still have prefixes before summarization. Let's first finish with this one, conf t router BGP 200, address family IPv4 unicast, to show run loopback 0 and loopback 1, and we do aggregate Here I'm going to aggregate also up to this one. So for each router, for each loopbacks, I will aggregate or summarize. This is going to be the main address, main prefix. 2001 db8 0 200 60. Aggregate address. Oh, sorry, I'm under IPv4. I need to go IPv6. Sorry, address family. Address family IPv6 unicast. Aggregate address. Like this, and let's go to router R3, do the same. I am under address family IPv6, aggregate address 2001 db8 0 300 60. So let's see what we have now to show IPv6 route BGP. So as you can see, we have aggregate summary address, original, summary address, original, and null for local summarization. So to remove these original prefixes, I need to use command summary only, which filter more specific routes from updates. And to show MPBGP IPv6 unicast 221 db8 0, let's say 2064. What we have here, we can see that is coming from this one. Which one is the best? This one is the best, and it's coming from router R2. So let's do this command summary only. Let's do on R2 only, and let's do on this one. So let's check now. Do show IPv6 BGP. Do show IPv6 route BGP. And now what we have, we still have from router R2 summary only. Let's wait, probably. Do show BGP IPv6 unicast 2001 db8 0 2000. I still have original prefixes 2064 60 atomic aggregate. Everything is good, but why do I still have these two? They're coming from router R3. Do show IPv6 route BGP. Oh, now everything is good. So we have a summary route to router R2 loopbacks and summary route to router R3 loopbacks. Let's check on router R2 to show IPv6 route BGP. And same here. And the last one R3 do show IPv6 route BGP. And the same you can see here. So now let's disable these two links. Interface G00 shut, interface G01 shut, and this one interface G02 shut, interface G03 shut. Now and show IPv6 route BGP. Let's check this one. Show BGP IPv6 unicast 2001 TB8 01060. Okay. So we have this route originated on router autonomous system 100 and advertised by 200 to this R3, and you see aggregated by 100. So let's go to 100 and remove this. Exit router BGP 100 address family IPv6 unicast, and this one. Let's remove it. No, paste, and let's do this router BGP. And let's do this summarization on router R2. Paste. And now let's check R3. Show IPv6 route BGP. We need to wait a little bit, so until we receive this aggregated route, because we still have. Oh yes, now it's good. So let's check now. Show IPv6 unicast. Sorry, so BGP IPv6 unicast, and this route. So as you can see now, it says that it is coming advertised by 200, aggregated by 200, and it has attribute atomic aggregate. So it seems like this route is coming from router R2. To change this, we need to add a set keyword, which does generate IS set pass information. So it saves information before aggregation, because now it acts like it removes information which it had before aggregation. Let's see what we have now. And now you can see, now we have the previous information before aggregation. So this keyword as set helps us to keep BGP pass information, this one. And now if you check, we didn't have IS pass, where we have that this originated from 100, but now we have this information. So this is everything I wanted to show you regarding MP-BGP. Thank you very much for your attention.